All right, guys, so this is the first video of section 4.6, and notice it's called the fundamental theorem, meaning the fundamental theorem of algebra. Okay, now if you remember that packet that we did was all about the fundamental theorem of algebra, so this should go right along with that packet. So most of what we cover, if not all, in this section is review, and you're hearing it for the second time. So hopefully that'll make this a little bit easier to understand. Okay, so just a couple things that we're going to go over first. Okay, how many zeros does a function have? So remember, the function has the same number of zeros as the degree of the function. So if we were to put this in standard form, okay, which it's not right now, you would see the degree of the function is 4. Okay, and therefore when it says how many zeros, we know that it has 4 zeros because the degree of the function and the number of zeros will always be the same. Write a polynomial in factored form that has zeros at 4, -6, and 3. So remember, we have talked that you can get your x-intercepts from your factors and your factors from your x-intercepts. Okay, well, the zeros are the same as the x-intercepts. So if 4 is a 0, then that means x minus 4 is a factor. And if -6 is a 0, that means x plus 6 is a factor. And if 3 is a 0, that means x minus 3 is a factor. Okay, so here would be our function that has zeros at 4, -6, and +3. Also talked about in the fundamental theorem packet that we did is that zeros come in pairs. That was a big topic. So if 4 minus 2i is a solution or a 0, then 4 plus 2i is also a solution. Okay, remember the conjugates and imaginary numbers always come in pairs. A 7th degree polynomial, this comes back to kind of the same thing we did up here, has 7 zeros. Now list all combinations. So remember that we have to have a even number of imaginary solutions because they all come in pairs. Okay, so we could have, we could have 7 real solutions, and if we have 7 real, we could have 0 imaginary. Okay, now we can't have 1 imaginary because they come in pairs, so we could also have 2 imaginary solutions. Okay, but if we had 2 imaginary solutions and we have 7 total solutions, okay, or 7 total zeros, maybe I should say, that means we would have 5 real zeros. Okay, same concept. Okay, we can't have 3 imaginary numbers or imaginary zeros, but we can have 4 because they come in pairs. So we could have 4 imaginary zeros, and if we have 4 imaginary zeros and 7 total, that means 3 of them would be real. Okay, and last but not least, if we don't have 4 imaginary numbers, we can't have 5, but we can have 6. And so if we have 6 imaginary numbers, we would then have 1 real. Okay, so notice on all of these, we have 7 total. Okay, and that's exactly what I want because we have a 7th degree polynomial, so we have 7 total zeros. All right, so Descartes' rule of signs, okay, tells us how many real positive zeros and real negative zeros we have. Now, it doesn't give us a definitive answer, okay? It gives us a possibility answer, okay? So if you remember, to get positive real solutions, okay, you look for the sign changes of f of x. Okay, this was in the fundamental theorem packet, but this is also one of the more confusing types, so a lot of you asked about this. Okay, so when I mean sign changes of f of x, here's our f of x. Okay, notice the leading coefficient is positive here, and then we change to where the next coefficient is negative. Okay, so that would be one sign change. Well, we stay from a negative to a negative, and then here we go from a negative to a positive or a minus to a plus. There's another sign change. Okay, plus stays a plus stays a plus. Oh, and then we have one more sign change. Okay, so we would say that f of x has 3 sign changes, meaning that we have 3 positive real solutions. Okay, or remember in the packet it says or less than by an even number. Or, okay, so less than by an even number. Well, the smallest even number is 2. So if we take 2 away from 3, we could also have 1 positive real solution. Okay, so 3 or 1 positive real solutions. Like I said, we don't get a definitive answer. We just have possibilities. Okay, now our negative real solutions, okay, come from the sign changes of f of negative x. Okay, so before we do that, we have to find our f of negative x. Okay, now remember, all that means is we plug negative x in for x. So we're going to take this here and just instead of an x, we're going to plug in negative x everywhere. So minus 5, negative x to the 5th, minus 3, negative x to the 4th, plus 3, negative x to the 3rd, plus 10 negative x squared plus negative x minus 9. Okay, now remember, any negative x to an even number is just going to be x to whatever power. Okay, so like negative x squared would be x squared, negative x to the 4th would be x 4th. And this comes from the fact that a negative x times a negative x, okay, is a positive x squared. Okay, now any negative x to an odd power will equal negative x to whatever power. Okay, and this comes from the fact that negative x times negative x is an x squared times another negative x would be a negative x cubed. Okay, so let's go clean this up. So negative x to the 6th power, because the 6 is even, this is just 2x to the 6th. Okay, I should probably put f of negative x here. Minus negative x to the 5th is a negative x to the 5th. So a minus and a minus would be a plus. Okay, and then a negative x to the 4th would just be a positive x to the 4th. So minus 3x to the 4th. A negative x to the 3rd would be a negative x cubed. So minus 3x cubed. Negative x squared is a positive x squared. So plus 10x squared minus x minus 9. Okay, so I found this whole different function where we have f of negative x. Okay, now once again, I want the sign changes from here. Okay, so I start with positive. So we have a positive, positive, there's no sign change. Here we go. Positive to a negative. Okay, there's one sign change. Negative stays a negative, negative goes to a positive, there's another sign change. And then positive goes back to a negative. There's another one. Okay, and then negative to a negative. So there's 3 sign changes. So just like our positive real solutions, we can say there's 3 or less than by an even number, so or 2 less than, or 1 negative real solution. Okay, we're guaranteed 1. We know we don't have 2. We could possibly have 3. Okay, so if I want to fill out this chart, guys, okay, here's all my different scenarios, okay, because remember, we have 3 or 1 here, we have 3 or 1 here. So if I have 3 positive real zeros, maybe I have 3 negative real zeros, okay, we know we have a degree of 6, so we have 6 total zeros. Okay, I'm gonna write 6 on all these because these all have to add up to 6. So I have 3 positive real, 3 negative real. That means I would have 0 imaginary. Okay, or maybe I have 3 positive real and 1 negative real. Okay, so if that's the case, this would account for 4 of my total 6, so that would mean I have 2 imaginary zeros. Now notice when I say less than by an even number on these, it comes from the fact that the imaginary come in pairs. Okay, so I can't take 1 imaginary number away. Okay, I have to take 2. That's why those decrease by 2. All right, so maybe I have 1 positive real and 3 negative real, so that would be 4, meaning that I'd have 2 imaginary. Okay, or my last thing, I could have 1, 1, which would just be 2, and then that would mean I'd have 4 imaginary zeros or 2 pairs. Okay, so these are my possibilities of my zeros. Okay, nothing's definitive, but these are my possibilities.